Hello and good afternoon. My name is Michael Sumuswatan and I'm going to report types of numbers. Natural numbers. Natural numbers help you count present objects or quantities. They are also called counting numbers. A set of natural numbers, usually represented by n, can be defined as a positive whole numbers beginning with 1. This is the natural numbers starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Example: addition property: 3 plus 4 is equal 7. Subtraction property: 7 minus 3 is equals 4. 3 minus 7 is equals negative 4. Multiplication property: 2 times 4 equals 8. And division property: 8 divided 2 equals 4. Whole numbers. Whole numbers are a set of numbers starting from 0 and increasing by 1 each time. Whole numbers do not include fractions, decimals, or negative numbers. They are positive integers. Starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Difference between whole numbers and natural numbers. Whole number. The set of whole numbers is W equals 2 versus 1 or 0, 1, 3. Smallest whole number is 0. Every natural number is a whole number. Natural number. The set of natural numbers is n equals curly braces 1, 2, 3. The smallest num natural number is 1. Every whole number is a natural number except 0. Even numbers. Any number that can be exactly divided by 2 is called as, as an even number. Even numbers always end up with the last digits as 0, 2, 4, 6, or 8. Some examples of even numbers are 2, 4, 6, 8, 10, 12, 14, 16. Example of even numbers: 2, 0, 2, 4, 6, 8, until 200 and 1000, so on. Odd numbers. Odd numbers are whole numbers that are not divisible by 2 without remainders. The last digit of an odd number is 1, 3, 5, 7, or 9. Odd numbers are just the opposite concept of even numbers. Example of odd numbers are 1, 3, 5, 7, 9, 11, until to 101 and to thousands, and so on. Example: this is the division property: 2 plus 4 is equals 6, even plus even equals even, 3 plus 5 is equals 8, odd plus odd is equals even, 6 plus 7 is equals 13, even plus odd is equals odd. Subtraction property: 8 plus 4 is 8 minus 4 is equals 4, even minus even is equals even, 9 minus 3 is equals 6, odd minus odd equals even, 10 minus 7 equals 3, even minus 10 minus 7 equals 3, even minus odd is equals odd. 2 times 8 is 2 times 4 is equals 8, even times even equals even, 3 times 5 is equals 15, odd times odd equals odd, 6 times 7 is equals 42, even times odd is equals even. Division property: 8 divide 2 equals 4, even divide even equals even, 9 divide 3 is equals 3, odd divide odd is equals odd, 6 divide 3 is equals 2, Even divide odd is equals even. Prime numbers. A prime number is a natural number that is greater than 1 that has exactly two factors, 1, 1 and itself. In other words, prime number is a number that cannot be formed by multiplying two smaller natural numbers since it has to include itself. So this is the examples: 2, 3, 5, 7, 11, 13, 17, 15 are the few examples of prime numbers. Example: 1 times 2 is equals to 1 times 3 equals 3, 1 times 4 is equals 5, 1 times 7 is equals 7, 1 times 11 is equals 11. The number 1 has the only one factor. 1 times 1 is equals 1. So it is not a prime number. It is not also a composite number. Composite numbers. Composite numbers are all numbers greater than 1 can be formed by multiplying two smaller positive integers. In other words, a composite number has more than two factors: 2, 4, 6, 9, 10, 12. Example: 2 times x equals 4, 3 times 2 equals 6, 3 times 3 equals 9, 4 times 3 is equals 12, 6 times 2 is equals 12. So we are here in measurements. Measurements is the basic concept, the study of mathematics and science. Measurement quantify the characteristics of an object or event, which we can compare with other things or events. Measurement is the most commonly used word whenever we deal with the division of quantity. Also, in taking a certain amount of things to accomplish a particular task in our daily existence, we often come across different measurement types of length, weight, time, etc. Types of measurement: time, length, weight, volume, and temperature. Time. Units for expressing time include seconds, minutes, hours, days, weeks, months, years, etc. Length. Using for measuring length including millimeters, centimeters, centimeters, meters, kilometers, etc. Weight. Units for expressing the weight and of certain objects include grams, kilograms, tons, etc. Volume units for expressing volume include cubic centimeter, liters, etc. Temperature. The major units of temperature include centigrade and Fahrenheit. Measurement instruments. Instruments are required to measure any type of quantity. For example, to measure weight, we require a weighing machine. To measure length, we require a scale or tape. Some measurements are given below. Measurement tape. The, bel- the below figure shows the measurement tape can be used to measure the length of objects or distances. This is the picture of measurement tape. An instrument for measuring time. The pendulum clock is the one of the instrument can be used to measure time. This is the picture. Instruments that measure weight. When in patterns. In mathematics, a pattern can be repeated arrangement of numbers, shapes, colors, and so on. The pattern can be related to any type of event or object. If the set of numbers are related to each other in a specific role, then the role or manner is called a pattern. Sometimes patterns are also known as a sequence. Patterns are finite or infinite in numbers. Types of numbers: arithmetic pattern, geometric pattern, and Fibonacci pattern. Arithmetic pattern. The arithmetic pattern is also known as a algebraic pattern. In an arithmetic pattern, the sequence are based on the addition or subtraction terms. If more or if two or more terms in the sequence are given, we can use addition or subtraction to find the arithmetic pattern. So this is an example. For example, 2, 4, 6, 8, blank, 14, blank. Now, we need to find the missing term in the sequence. So here, we can use the addition process to figure out the missing terms in the patterns. In the pattern, the rule used is add 2 in the previous term to get the next term. In the example given above, taken the second term 4, if we add 2 to the second term 4, we get the third term 6. 2 plus 4 is equal 6. That is the third term. Similarly, we can find the unknown terms in the sequence. The first missing term, the previous term is 10. Therefore, 10 plus 2 is equals 10. Oh, 12. So we have the 12. Second missing term, the previous term is 14. So 14 plus 2 is equal 16. So we have the 16. Hence, the complete arithmetic pattern is 2, 4, 6, 8, 10, 12, 14, 16. Geometric pattern. The geometric pattern is defined as the sequence of numbers that are based on the multiplication and division operation. Similar to the arithmetic pattern, if two or more numbers in the sequence are provided, we can easily find the unknown terms in the pattern using multiplication and division operation. For example, 8, 16, 32, blank, 128, blank. It is a geometric pattern, as each term in the sequence can be obtained by multiplying 2 with the previous term. For example, 32 is the third term in the sequence, which is obtained by multiplying 2 with the previous term 16. Likewise, we can find the unknown terms in the geometric pattern. First missing term, the previous term is 32 multiplied by 32 by 2, we get 64. So 64 is the answer. The second missing term, the previous term is 128. Multiply 128 by 2. So we get 256. So the missing numbers are 64 and 226. Hence, the complete geometric pattern is 16, 32, 64, 128, and 256. Fibonacci pattern. The Fibonacci pattern is defined as the sequence of numbers in which each term in the sequence is obtained by adding two terms before it starting with the numbers 0 and 1. The Fibonacci pattern is given as 0, 1, 1, 2, 3, 5, 8, 13, and so on. Fibonacci sequence 0, 1, 1, 2, 3, 5, 8, 13, 21, blank 55. Here the third term is 1 is obtained by adding the first and second term. 0 plus 1 is equal 0. Similarly, 2 is obtained by adding the second term and the third term. 1 plus 1 is equals 2. 3 is obtained by adding the and fourth term. 1 plus 2 and so on. For example, the next term after 21 can be found by adding 13 and 21. Therefore, the next term is equal to 34. Shape. Shapes define the boundary of an object can be differentiated in many ways based on their properties. Shapes are defined by boundary which is made by combining the curves, points, line, and line segments. Each shape has a name depending upon structure. A few examples of the shapes are circles, squares, rectangles, triangles, and so on. Types of shape. Shapes can be classified into various categories. Before classifying shapes further into separate structures, let us see the different types of shapes examples. Open shapes. Open shapes are not continuous and are made up of line segments or curves, which do not meet. Letter C is an example of an open shape. Closed shape. Closed shape can be traced without any break. They can start and end in the same place. Letter D is an example of a closed shape. This is the picture of open shape and closed shape. Order. Each shape is classified into on the basis of dimensions it has. In this section, we will discuss the two major types of shapes. Two-dimensional, so called 2D. 2D shapes, as the name suggests, have only two these measurements, length and width. Three-dimensional shape, the 3D shape, have length, width, and height. Square is a 2D shape, whereas cube is a 3D shape. So this is the shape. We have the 3D shapes and 2D shapes. The cube in 3D shapes we have cube, 2D, square, cuboid, rectangle, cylinder, circle, cone, triangle, sphere, oval. So we have here the list of shapes. So we have more examples here. A circle is a closed shape. It is categorized as a two-dimensional geometric shape that can be round in structure. An oval is an elongated shape, slightly similar to a. It has no straight lines or corners. For example, the number 0. A square is a 2D shape that can be formed by four sides. The length of each side is equal in measurement. For example, a chessboard and a carom board. Triangle. A triangle is a shape with three sides and is categorized as a two-dimensional geometric shape. For example, the shape of tangy nachos, all sides of cheese burst pizza. Rectangle has a four side. It has a two-dimensional geometric shape in which the length of the opposite sides is equal. For example, laptop, screen, touchscreens, mobile phones, etc. Polygon. Polygon is a close two-dimensional figure with three or more straight lines. For example, windows and doors. Cube. A cube is a closed three-dimensional geometric pattern. It is made up with six squares. It has six faces. For example, a Rubik's cube, a Ludo cube, or an ice cube. Cuboid. Cuboid is another is three-dimensional shape that is formed using rectangles. For example, a, a duster, a book, and pencil. A sphere. Sphere is a solid shape that is similar to a ball. It is closed three-dimensional shape formed using circular base. For example, football, basketball, etc. As cylinder. Cylinder is a solid shape that has two flat ends of circular formation. It is a three-dimensional figure which is formed by folding a rectangle. For example, cold drink cans, pool noodles, water bottles. Cone. A cone is a solid three-dimensional geometric shape with a flat base. The base is a circular shape. It has pointed edge at the top called the apex. For example, ice cream cone, clown hat, etc. So that's it. Report and thank you.